Hi everyone, we are going to be moving on to activity 3 now. So I'm going to first share the PowerPoint. Okay. So I also want to apologize because on the last video, when I shared the TED Talk, I noticed that you guys actually were not watching the TED Talk with me. It's just like pure silence and you guys are just viewing my PowerPoint. I didn't switch over on Zoom. I only switched over on my computer, so I apologize for that. I will go ahead and post that TED Talk. It's very brief. I think it's about 4 or 5 minutes, so go ahead and watch that on your own. If I have time, I will redo that video, but if not, I'll just post it so you guys can watch it on your own. So if we were in lab, we would be learning how to use different instrumentation to determine length, mass, and volume. So if we were in lab, you would have your lab bench with an balance on it. You would have a ruler and you would have graduated cylinders. And you would be required to measure the length of different wooden blocks using a ruler. You would also be required to measure the mass or weigh out the mass of different substances using a balance. Your book refers to it, or your manual refers to it as an electronic balance. I call it an analytical balance. And then you would also weigh out or measure out volumes using a graduated cylinder. So as far as determining length using a ruler, this is something you guys are probably very accustomed to and familiar with. The only thing is when you measure out the length, you would want to make sure you are using the metric system. So make sure you're not using feet or inches. Use something like centimeters instead. And then to determine mass, like I said, we would use a balance. I kind of wrote out how you would use a balance, but we're also going to watch a video. Hopefully I'm able to share the video properly this time. So the first thing is that you want to make sure that your balance is on a flat, stable surface indoors. So you want to make sure it's away from doors that could cause any shaking or vibration or vents, because this can affect the position of your balance. Next, you also want to make sure that wherever your balance was calibrated, use that balance in that same location. This is especially important for government laboratories where quality control is a big factor. So if you get something calibrated in a specific location, you are not allowed to move that instrument to another room and use it there. It must be on that same surface it was calibrated. So you want to press on button and wait for the balance to show zeros on the digital screen. You would use either tongs or gloves to place an empty container onto your scale. This can be a weigh boat for larger substances or a paper, like a weight paper, for smaller substances. Sometimes you are required to use tongs, especially when fingerprints or other greases can affect your measurements. So it really depends on what you're measuring. Once you put your weigh boat on the scale, you're going to want to tare your scale. So go back to zeros so that that weight of the container is deducted from future calculations. And then you will carefully add the substance to the container or the paper, however you are weighing out your substance. Ideally, you want to open these glass doors and put your substance directly onto the paper. Usually that's how you do it. Sometimes it's not possible to do that, but that is ideally how you would weigh something out. And we're going to watch this video so you can see how it is properly done. So let me see. Let me make sure I go to the video this time. Okay. Okay, so hopefully I was able to share that video properly this time. Go back to the... Okay, so that is how you would use an analytical balance in the laboratory. So if you wanted to determine volume, you typically would use a graduated cylinder. So these are images of graduated cylinders here. So when you pour your liquid or solvent or solution into the graduated cylinder, you always want to take the measurement from the bottom of the meniscus. So as you can see, these liquids tend to cling to the sides of this graduated cylinder and create this U shape. This U shape is called a meniscus and results from the cohesive and adhesive properties of liquids against the glass or plastic tube. So what I mean, here, let me go ahead and change this pointer again. So water is very notorious for having both cohesive and adhesive properties. So cohesive means that water molecules like to interact with each other. So this has to do with the intramolecular forces. So water wants to cling to other water. And a great example of this is if you were to fill up a glass cup with water, you would notice that it wouldn't fill over, or it wouldn't spill over the sides. It tends to really clump up to each other at the top, even when it looks like it's at the point where it should begin to spill over. And this is because of those intramolecular forces. Water also has unique adhesive properties. So it likes to stick to certain glasses and plastics. So a good example of this is if you have two glass cups, you have one glass cup that is empty and one glass cup that is full of water. If you were to pour the glass cup that is full of water, the water into the empty glass cup, if you were to pour it with both glass cups touching at the rims, you will see that the water wants to stick to the glass, so it's going to spill all over. You kind of have to waterfall it in a way so that it can't stick to the plastic and it has to free fall into the other glass cup. So this is why we measure from the bottom of the meniscus, because of these type of properties that most of our solutions will have. So to measure liquids in a graduated cylinder, you always want to read from the lowest liquid level. And you also always want to pay attention to the scale of your graduated cylinders. So here we have 20 and here we have 30. So this is going to be 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. But sometimes it will jump in increments of 2. So it'll be 20, 22, 24, 26, 28, and 30. It won't have those other lines in between. Or sometimes this will be your 20 and this will be your 30. So you always have to pay attention to those, the scale of your cylinders. Okay, so here are 3 graduated cylinders that are filled up with different amounts of this blue solution. I have completed the first one for you. So in the first one, you have 4.5 mils of, I guess, let's say water in it. So go ahead and complete the next 2. Like I said, you always want to pay attention to the graduations of these 3 different cylinders. And you want to remember to read from the bottom of the meniscus, not from the top. So you always read from the bottom. Another thing that you take a lot in labs are temperatures. So like I said, in government labs, quality control is a big factor. So every morning we have to take magnehelic readings of all our isolation rooms. We also have to take thermometer readings of every refrigerator and freezer we have in our laboratory. So the first thing to bring up is that in laboratories, you're going to use Celsius. You're not going to use Fahrenheit, and you're going to report all your data as Celsius. The second thing is just how to take the measurement. You just want to read from where you see the number is at. So there is some for you to practice here as well. So once again, always make sure you're paying attention to your scale. This thermometer is reading Celsius, which all thermometers in laboratories will read Celsius, but just you still want to pay attention to that. And I've done this one here. Room temperature is at 20, 21, 22. So you would record that as 22 degrees Celsius. So if you were to keep going, it's 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So you just want to make sure you pay attention to these graduations here as well. So that concludes how to use or how to determine mass, length, volumes, and temperatures using common instrumentations in laboratories. Go ahead and work on those activities on your own, and if you have any questions, let me know.